be represented in terms of linear combination of harmonically related complex exponential, and we require infinite number of linear combination of harmonically related complex exponential to represent a periodic signal. So xt equals to summation of k equals to minus infinite to infinite ak e to the power j omega naught kt, where ak is the kth Fourier series coefficient and omega naught k is the frequency of kth component associated with ak. And in order to find out the value of ak, which is a Fourier series coefficient, we have a mathematical relation 1 by t integration over a time, over a period, x of t e to the power j k omega naught t dt, where omega naught or f naught is known as the fundamental frequency or the fundamental harmonics. So this form of representing the Fourier series is known as complex exponential form. Another form of representing the Fourier series is known as quadratic Fourier series or trigonometric Fourier series. The quadratic Fourier series or the trigonometric Fourier series is nothing but the same equation you can achieve with the help of the complex exponential equation which I derived earlier. So this x of t can have a naught plus k summation of k equals to 1 to infinite ak cos of k omega naught t plus 1 to infinite vk sine of k omega naught t, where a naught is the dc component that is present in that part, and a naught can be calculated by this mathematical equation 1 by t integration over a time period xt dt. ak is 2 by t integration over a time period xt cos of k omega naught t dt. Similarly, bk is 2 by t. So this form, as I already told, is known as trigonometric Fourier series or quadratic Fourier series. Here, the important thing is that to understand the concept of Fourier series, not the mathematical equation which is written over here. Because once you have the mathematical equation, you have a signal x of t, you will be easily able to calculate the Fourier series coefficient a naught, ak or bk. The important thing is that to understand the concept behind this I already told. Again, I am repeating. According to the Fourier, if I talk about a continuous time signal, any continuous time periodic signal can be represented as a linear combination of harmonically related complex exponentials. Now, another form of the Fourier series which you can achieve with the help of the same equation is known as the polar form. How can you make the polar form with the help of trigonometric Fourier series? We have now xt is equals to c naught plus k equals to 1 to infinite ck cos of k omega naught t minus phi k, where c naught is equals to a naught, ck is root of ak square plus bk square, and phi k is nothing but this is tan inverse bk by ak, where ck provides information about spectral amplitudes of the component kf naught and phi k is the phase associated with this complex. So C naught here is known as the DC component. Now this equation I already told exponential Fourier series. Now let's talk or begin with the few numericals to understand the real concept of the Fourier series. Now we have a signal, let's say xt equals to cos of omega naught t. And cos of omega naught t, since this is a periodic signal, and of course it can be represented by in terms of Fourier series. So the mathematical equation of the Fourier series in complex form is n equals to minus infinite to infinite Cn e to the power j omega naught and t. If I split this cos of omega naught t, or if I want to write cos of omega naught t in terms of complex exponential, so we have half e to the power j omega naught t plus half e to the power minus j omega naught t. And if I compare this mathematical equation to the right side, so we found that we have only two components, which is your C1 and C minus 1. And the value of these two Fourier series coefficients C1 and C minus 1 is 1 by 2. And for rest of the values of n, these are 0. So that means we have two Fourier series coefficients lying at n equals to 1 and n equals to minus 1 with their amplitudes half is capable of representing.
Sir,
Yes.
there you have written Cn is equal to 0 for n is not equal to 1. Minus
Yes.
1 should be added there. For n is not equal to 1 and minus 1 both.
Cn equals to 0 for n is not equals to 1. Okay, you can add.
Okay, sir.
So this represents there are only two Fourier series coefficients, or there is a linear combination of only two harmonically related signals which is capable of representing cos of omega naught t, right? In general, there can be infinite number of harmonically related components which is capable of representing your periodic signal, but it depends on the type of the periodic signal. For cos of omega naught t, there is only two complex exponential which is capable of representing the original signal, which is lying at n equals to 1 and minus. Similarly, for sine omega naught t, which I can represent half of e to the power j omega naught t minus e to the power minus j omega naught t divided by j. So C1 and C minus 1 comes out to be 1 by 2j or minus 1 by 2j. Again, there are only two Fourier series coefficient which is capable of representing your original signal, which is a periodic signal sine of omega naught t. Now let's talk about next signal cos 2t plus pi by 4. If you expand this like cos 2t sine pi by 4 minus sine 2t cos pi by 4, and if I write 1 by root 2 cos of 2t minus sine of 2t, so here omega naught is 2. Remind this thing. This is an important thing. Omega naught is 2. And if I want to write cos of 2t sine of 2t in terms of exponential to find out the Fourier series coefficient just by comparing the complex exponential Fourier series. So we have this e to the power root 2t plus e to the power, sorry, e to the power j2t plus e to the power minus j2t minus 1 by 2j e to the power j2t minus 1 by e to the power minus j2t. And if I take e to the power j2t common or minus j2t common, so we have 1 by root 2 1 plus j and 1 by 2 root 2 1 minus j. So again, we have two Fourier series coefficient C1 and C minus 1. Can you tell me why they are C1 and C minus 1? Why not C2 or C minus 2?
Because of that minus j2t, the
So
n should be 1 for minus 1.
because of omega naught is 2,
Yes, sir.
right? In the previous case, omega naught equals to 1. So this is how you will be able to calculate the Fourier series coefficient. Now again we have a signal cos 4t 4t plus sine 60. You have to find out the Fourier series coefficient corresponding to this signal. So what is our first duty to find out?
Sir, find out omega naught firstly.
Omega naught. And for finding out omega naught, what should be the condition? In order to find out the Fourier series coefficient of any signal, the signal must be what?
Periodic and continuous.
Signal must be periodic. Whether it is continuous or discrete hardly matters. Uh, Here I am talking about continuous. So continuous signal is there. It should be periodic. So first we need to check whether the composite signal is periodic or not. So let's try. In order to have a signal to be periodic, what is the condition? The ratio of the time period of the two signal must be.
Real number.
So let's find out the time period. Omega naught 1 is 4, omega naught 2 is 6. So tell me about the time period.
Sir, 1 by 4 and 1 by 6. T1, T2.
Now let's talk about the ratio of these two.
6 by 4 or 4 by 6.
So what do you think?
Real number, sir.
Huh?
Real number.
The time period of the first signal is 2 pi by 4. The time period of the second signal is 2 pi by 6. And the ratio of these two is 6 by 4, which is a rational number. And the time period of the overall signal must be the LCM of T1 and T2, which comes out to be pi. पाई जब इसका टाइम पीरियड आ रहा है ओवरऑल सिग्नल का तो उसका ओमेगा नॉट कितना होना चाहिए
2.
omega naught will be 2. Now can you find out the Fourier series coefficient for this? सभी लोग ट्राई कीजिए जरा cos 40 plus sin 60 के लिए ओमेगा नॉट अगर 2 है what are the Fourier series coefficients? हेलो।
We are
क्या
connecting.
आंसर है? अभी तक तो आ जाना चाहिए यार, इतना टाइम थोड़ी लगता है।